In this video, I'll cover the essentials of how logistic regression works. I'll talk about the logistic response function and also the sequence of steps to estimate probability. In a previous show, I talked about why multiple linear regression does not work well when you have a binary outcome. So when you have a success or failure, or a yes or no, or a true or false outcome. So we need a different solution. We'd like the outcome to be the probability that an instance will belong to the class of interest. We need to be able to have one or more predictors involved, and we'd like the predictors to result in a value that ranges between 0 and 1 for probability. The problem without help is that the standard multiple linear regression equation does not meet our constraints. The solution is the logistic response function. Put any value between negative and positive infinity in for the z value, and the p response will be between 0 and 1. And this is what it looks like when you chart the values of z in the logistic response function, and these are the probabilities up and down here. So here's a probability of 1, here's a probability of 0. You can see the S-shaped curve that works along here. This little z here is sometimes referred to as the legit, and so you can take the e and replace it with the word legit and it still would be correct. The e is 2.718, which is the base of natural logarithms, and z represents the total contribution of all predictor variables used in the model. So in a sense, we need to be able to solve for z, and z is the sum total of all the contributions that all the predictors will make for a model. And then p presents the probability of a particular outcome, given that we have z. So if we substitute the classic multiple linear regression equation in for z, or for legit, in other words, we get this. And so if we can find a way to be able to figure out what these betas are that we can multiply by the values of x and do that correctly, then we should be able to get the correct probability of p. Let's look at an example of how this can work. So here we have people that have had a first heart attack, and we're trying to figure out the odds and probability of them having a second heart attack. We have some information about them. We find out who has had second heart attacks, so we have information to be able to train our model. We also have which of these people took an anger management training class and which ones didn't. We can see here that if you don't take the anger management training class, most people had heart attacks. Out of the 11 people that did not take the anger management training class, 7 had heart attacks and 4 did not. Out of the 9 people that did take the anger management training class, only 3 had heart attacks and 6 did not. Now we can translate this easily into odds, because odds are by definition are the number of successes. Successes would be finding a heart attack compared to the number of not finding heart attacks. So we have 7 heart attacks and 4 that are not, and that equals 1.75. If we divide 4 into 7, we get 1.75. So the odds of a second heart attack, if you have not had the training, is 1.75. The probability of a second heart attack is always going to be the successes over the successes plus the failures. So we're going to have 7 heart attacks over 7 plus 4, and that equals the probability of 0.636. In this simple example, then, it's easy to calculate the odds and it's easy to calculate the probabilities. Now let's look at the other scenario where people did take the training. The odds of a second heart attack is 3 heart attacks to 6. So that's 3 to 6, or the odds of 0.5. The probability of a second heart attack is the 3 successes over the 3 plus the 6 failures, and that equals 0.333. So we have a 1/3 chance of having a heart attack if we have taken the training, and we have almost a 2/3 chance of doing it if we've not taken the training. And understanding this will help us as we work through the rest of this problem. So when we're trying to work through this logistic regression process, there's a sequence of steps that we take to estimate probability of coming up with the thing that we're looking for. So for each unique combination of predictor variables in the data sample, we want to calculate the odds. And we just did this. It sounds complicated, but essentially here we did. Here was our zeros and here was our ones, and we calculated our odds of successes and to failures, our ratio of successes to failures. So what we would do in this case, since we only have one predictor, then this is the unique value of that predictor, and then this is the other value when that's not true, and we can see that the odds are different. The odds for having a heart attack are different if you've not been trained versus if you have been trained. So what we want to do is we want to take the combination, the unique combination of predictor variables. In this case, it's very simple. It's only yes or no for one predictor. And we want to see how that relates to the odds of finding what we're looking for. And then we want to convert those odds to single number form, which we did back here. We found out our odds in a ratio, and then we calculated the single number form. So if you are in this situation without the training, there's a 1.75 to 1 likelihood of having a heart attack. So for every person that doesn't have a heart attack, 1.75 people will have a heart attack. We also translated this odds into 1. So it's 0.5. There's 3 people that have a heart attack, and in other words, that's the success class in what we're looking for, and there's 6 that don't. So that's 3 to 6, or 0.5. So when odds are translated into single value form, then the odds here are 0.5. So we've done the first step. The next step is to calculate the legit, which is the symbol Z, by taking the natural log of the odds. And the way this is done in Excel is if we'll put the odds number in the function that is ln for natural log, then it will calculate the legit. It will take the natural log. So in other words, what we need to do is we need to take the natural log of the odds, and here it is in single number form, and we'd also take the natural log of this value in single number form, and that would give us the natural logs of those numbers. So when we do this, then if we take 1.75 and take the natural log, we get 0.56. If we take 0.5 and take the natural log, we get a negative 0.6931. So we've now done the second step. At this point, we have a Z value for each unique combination of values for predictor variables. In a sense, it's like having a Y value, an outcome, since the Z represents the sum result of multiplying the betas times the X's and summing them all up across all the variables. In a sense, Z becomes like Y in multiple linear regression. So if we have a Z and we have known X's, and if we can figure out what these beta coefficients are, then we're going to be in a position to be able to find the relationship between X values and the Z value. So we call this fitting. So we're going to take all of our Z values, which are those natural logs of odds, and we're going to associate with them the values of the X's, and we're going to let the software do fitting, and that's where it will basically take all the known values of X's, and we'll take the known value for Z, which we just calculated, and it will figure out which combination of betas does the best job of making that equation work. So now we should have figured out what these beta coefficients are. The software has done its job. We gave it a known Z. We gave it series values of known X's, and we said fit the B's. Find the beta coefficients that are going to make that fit the best. So now, since we know what these B's are, we should be able to plug X's in these predictor values, multiply them times the beta coefficients, and then sum up all the results and get Z. That's the essence of what we're doing. Once we've done that, once we have the value for Z, we can plug Z into our logistic response function and calculate probability. And this will estimate the probability of finding the success class. And then finally, once we know what P is, then we'll set the cutoff and figure out what that probability needs to be in order to us to say that something is a success. So for example, most data mining algorithms set that default for 0.5 as the probability for cutoff, but it can be changed. You could say the probability has to be at least a 0.8 for us to consider something a success. And we could manipulate that using the data mining software. So let's go through this entire process and watch the math work. So we did this before. We figured out what the odds were here for the people without anger management training. Then we took the natural log to calculate the legit, and that was 0.56. We also know what the probability is because it's the number of heart attacks over heart attacks and non-heart attacks. So we know what our answer should be. And so we should be able to take legit, this value, plug it into the logistic response function, and calculate what the probability is for these people in this sort of scenario to have a heart attack. And it actually works. When we raise e to the negative 0.56, we get this value, and then it turns out to be exactly what this value is. So we calculated this manually by going over here and counting the successes and the failures and figuring out what the probability is. And then when we get the very same thing when we come up here and we take the legit, the natural log of the odds. And so it works when we plug that value back in and we get probability. It also works down here. So the odds of the second heart attack was 0.5. If we take the natural log of that, we get a negative 0.6931. We know the probability here already. There's 3 heart attacks to 6 non-heart attacks. So that's 3 over 9. There's a 1/3 chance of having a second heart attack if you've had the training. So since this legit value is known now, we can plug this into our logistic response function and calculate the probability of having a second heart attack, which happens to be exactly what we calculated here before. So what you've just seen is you've seen the entire process of how this works. We calculate the odds given a unique set of predictors. In this case, I only had one predictor, but I could have had more than one predictors, and it would have looked for all the unique values and combinations of those values and calculated the odds for each unique combinations of values across those predictors. Once we've done that, then we can take the odds and calculate legit, and then once we know that, we can plug this into the logistic response equation for z and calculate the probability that that outcome will happen. Another way we can calculate the probabilities of an outcome happening is we can derive what the odds are. In other words, if we take e and raise it to the z, if we take the inverse log of legit, once we've calculated legit in the fashion I explained just a minute ago, then what we can do is we can plug this legit back into this equation, which is the sum of all of these b's times the x values, and we can actually calculate the odds. In other words, the way to think about that is up here, we took the odds and then took the natural log of it and got this value right here, and this time we'll go backwards. We'll say, okay, if this is what legit is, I'm going to go do the inverse natural log, and I'm going to calculate this number again. So by doing that, then, if we take e, which is 2.78, and we raise it to whatever legit is, it'll give us the odds that we're going to have this value of 1, which would be the success class that we're looking for. And remember, success doesn't mean it's a happy ending. Success means it's the thing we're looking for. In this case, heart attacks is what we're looking for, so that is our success class. Once we know what the odds are, then we can plug odds into this equation and we can find the answer for what the probability is, because this equation lets us go from odds to probabilities. So we have 2 ways of finding probabilities. One is we can go through this entire process and find the legit, and we can plug it into the logistic response function and calculate probabilities. The second way is to calculate the odds. If we take the inverse natural log of e, which is like saying we're going to take e and raise it to legit, that will give us odds, and once we have odds, we can calculate probability from the odds. That is the fundamental process of doing logistic regression, and that's how the math works.